In our earlier program, it was observed that normal consistency of cement helps in determining initial and final setting time of cement. The normal consistency also plays a vital role in ascertaining the compressive strength as well as the soundness of cement. The structural adequacy of any building may depend upon the compressive strength of cement concrete. Cement with low compressive strength may result in weak concrete, which in turn may lead to failure of the structure. Compression testing machine helps in determining the compressive strength of cement, which is an important check employed to determine the suitability of cement for preparing cement concrete. The compressive strength of cement is tested by cement mortar cubes prepared with 1 part by weight of cement and 3 parts by weight of standard sand. The standard sand comprises 3 different grades of sand. The particle size of grade 1 sand varies from 2 to 1 millimeter. Grade 2 sand varies from 1 millimeter to 500 microns, and grade 3 sand varies from 500 microns to 90 microns. Let us now start with the testing of compressive strength of cement. For this test, measure 200 grams each of standard sand of grade 1, grade 2 and grade 3. Place the measured quantity of each grade of sand in the enamel tray. The total weight of sand now becomes 600 grams, which is then thoroughly mixed in the dry state. Now measure 200 grams of cement. Add to it the measured quantity of sand and dry mix it thoroughly. Now measure water equal to P divided by 4 plus 3 times the combined weight of cement and standard sand measured. Therefore, the required water content is equal to 26 divided by 4 plus 3 multiplied by 1 over 100 multiplied by 800, which is equal to 76 milliliter, where 26 is the normal consistency of cement and 800 is the combined weight of cement and sand. Before adding the measured quantity of water to the dry cement sand mix, apply oil to all the interior faces of the mold, each side of which measures 7.06 centimeter. After oiling all the inner faces of the mold, including the base plate, place the assembled mold on the table of the standard vibrating machine. Firmly hold the mold in position by means of suitable clamps provided. Now add the measured quantity of water, that is 76 milliliter, to the dry mix of cement and sand and simultaneously start the stopwatch. The total time of mixing and filling of the mold should be completed within 3 to 5 minutes of adding the water. Place the mortar in the clamped mold through hopper on the top. Switch on the vibrating machine. This vibrating machine has standard vibrations of 1200 plus minus 400 vibrations per minute. The cement cubes are compacted by giving standard vibrations for 2 minutes. Switch off the vibrating machine after the stipulated time of 2 minutes. Unclamp the mold. Remove the mold carefully from the machine and place it on a level surface. Finish the surface of the mortar cube with a trowel. The other 2 cement cubes are also filled and compacted in the mold in a similar manner. After the elapse of initial setting time of cement, which is generally 30 minutes, the cubes are covered with wet gunny bag. This helps in maintaining the relative humidity of 90% and temperature control of 27 plus minus 3 degrees Celsius. At the end of 24 hours, the gunny bag is taken off. The mold is then dismantled to dislodge the cast cement cube. A gentle tap with the hammer on free ends helps in the easy removal of cube without damaging its ends. The other two cubes are also removed from the mold in a similar fashion. The cubes are then placed under water at a temperature of 27 plus minus 3 degrees Celsius. For testing of the cubes at the required age, take out the cubes just half an hour prior to the testing. Before placing the cubes in the compression testing machine, measure the side of the cube and record it. Place the cube under the testing plates of the compression testing machine. To lock the arrangement, tighten the knob. Switch on the machine so that uniform hydraulic load is applied on the cube under test. Switch off the machine when the dial gauge shows the constant load reading and the cubes are crushed. Note down this crushing load, which is 8 tons in this case. Redo the entire operation for knowing the crushing load for the other two cubes at the required age. The compressive strength of cement is given as load divided by the area of the cube. The crushing load in this case is 8 tons or 8,000 kg. The area of the cube is 7 centimeter multiplied by 7 centimeter, which is equal to 49 centimeter square. Therefore, the compressive strength of cement at 3 days is equal to 8,000 divided by 49, which is approximately equal to 160 kilogram per centimeter square. This value of compressive strength of cement can be compared with the specified values given in the BIS code depending upon the type of cement tested. For example, the compressive strength of cement at 3 days for ordinary Portland cement is 160 kg per centimeter square, whereas for Pozzolana Portland cement, no standard values are specified. At 7 days, the standard value of ordinary Portland cement is 220 kg per centimeter square, and for Pozzolana Portland cement, it is 175 kg per centimeter square. Likewise, the compressive strength values of other cements can also be tested and compared with the given codal values. Soundness of cement can be attributed to the volumetric stability of cement during the hardening process. In cement, cracks are developed due to the slaking of free lime and magnesia with water, which is due to increase in volume of set cement mass. Concept of soundness can be explained with the help of two similar earthen pitchers. On striking the first, we get continuous ringing sound, whereas in the second pitcher, the sound is dull, indicating discontinuity in the movement of sound waves, which is due to the existence of cracks in the body of the pitcher. In cement, cracks are developed due to the presence of free lime and magnesia, which slakes slowly in the presence of water and increases manifold in volume. The test of soundness is conducted with the help of La Chatelier's mold. Measure 100 grams of cement sample. Place the sample in the enamel tray. Now measure 0.78 times P of clean water in the graduated cylinder. Therefore, the total quantity of water required is equal to 0.78 multiplied by 26 divided by 100 multiplied by 100, which comes to 20.28 milliliter, where P is the normal consistency of cement sample, which is taken as 26% in this case. Start the stopwatch the moment measured quantity of water is added to the cement sample. Mixing should be completed within 3 to 5 minutes till cement paste of uniform consistency is formed. Fill the La Chatelier's mold lying on the glass plate with the prepared cement paste. Now cover the filled up mold with another glass plate and place a 50-gram weight on this plate. Tie up the whole assembly with a thread. Now measure the distance between the tips of the indicators, which is 13 millimeter in this case. The second mold is filled with fresh cement paste. The entire procedure of filling, covering with glass plate, placing the weight and tying with the thread is repeated. The distance between the tips of the indicators is 14 millimeter in the case of the second mold. Both the molds are then placed under water at a temperature of 27 to 32 degrees Celsius for a period of 24 hours, during which slaking of lime and magnesia take place. At the end of 24 hours, heat the water with assembly submerged at a rate so that it starts boiling within 25 to 30 minutes. This is done to accelerate the slaking of magnesia with water. Keep the water boiling for 3 hours. At the end of 3 hours, remove the assembly from the hot plate and allow it to cool. Take out the molds from the water and measure the distance between the indicator ends. The distance between the indicator points of the first mold is 18 millimeter. In the case of the second mold, the distance is 23 millimeter. Recapitulating our initial record of readings, in the case of first mold, it is 13 millimeter, and for the second mold, 14 millimeter. The final reading for the first mold is 18 millimeter, and for the second mold it is 23 millimeter. The difference in the initial and final readings for the first mold is 18 minus 13 is equal to 5 millimeter, and for the second mold it is 23 minus 14 equal to 9 millimeter. Mean expansion value of cement can be calculated as 5 plus 9 divided by 2, which is equal to 7 millimeter. Since the value obtained is less than 10 millimeter, thereby satisfying the codal requirements, the cement is said to be sound. In the case of unsound cement, the aerated cement test is carried out, which involves spreading out the cement in 75 millimeter thick layer in an atmosphere of relative humidity of 50 to 80%, maintaining a temperature of 27 plus minus 3 degrees Celsius and keeping it for 7 days. Retest this aerated cement sample. If the cement sample fails to meet the BIS requirements even after aeration test, the sample may be rejected, especially for water retaining structures.